This video is about the remainder theorem and the factor theorem, okay? The factor theorem is based on the remainder theorem, so there's a really close relationship here. And we're going to use this to help us factor polynomials that we couldn't otherwise factor with the tools we've learned to this point, all right? So the remainder theorem states that if you divide a polynomial, which we're going to call f of x for now, by a linear polynomial of the form x minus a, whatever the remainder is, okay, when you go through that process, whatever the remainder is, that's the equivalent value to f of a. So what this does, it allows us to evaluate more complicated functions using longer synthetic division, okay? The factor theorem comes from the remainder theorem. When dividing f of x by x minus a, if your remainder is 0, that means that divisor, that x minus a linear polynomial that we divided by, is going to be a factor of the polynomial in f of x, okay? And that makes a 0 of the polynomial. So we can use that to factor. We can also use that to help us graph polynomials, all right? So we want to use the remainder theorem here to evaluate a couple of functions, okay? Now we want to evaluate this function f of x equal to x squared plus 5x plus 12 for the value f of negative 11. So what you could do, obviously, is just plug negative 11 in here and here, okay? But there might be some functions that are more complicated, and you might be plugging in values that aren't as easy to just plug in and do some quick calculations, all right? So we want to use synthetic division. Now, whatever our remainder is here in just a second when we finish the process, that's going to be the value when you plug in negative 11, okay? If you want to right now, you can pause the video, plug negative 11 in here and here, do the math, and find the value. That way, you can verify that happens to be the case when we get our remainder in just a second, okay? So synthetic division, we're going to put our value, our a value here out front. We've got our coefficients of x squared, x, and x to the 0 here, 1, positive 5, and positive 12. And let's go through the synthetic division steps. So first thing we want to do is bring down the 1. Let's multiply negative 11 times 1. We get negative 11. Add those two values, I get negative 6. Multiply negative 11 times negative 6, you get positive 66. And we get a remainder of 78. Now, if you plugged in negative 11 and already found that, that should verify that f of negative 11 is positive 78, okay? Now, this function's a little more complicated. We've got a cubic function that we're dealing with, and we're plugging in negative 8, okay? So let's go through the synthetic division steps. So we're going to bring down the 1. We're going to multiply negative 8 times 1. Then we're going to add those two values. We get negative 4. Multiply negative 8 times negative 4. Get positive 32. Add these, you get 37. Then multiply negative 8 times 37, which is negative 296. And then when we add those two together, we get our remainder of negative 294. So f of negative 8 equals negative 294. Okay. Notice that the remainder in neither of these cases was 0. Therefore, I know negative 11 is not a 0 of this function. I know negative 8 is not a 0 of this function. I also know x plus 11 is not a factor of this quadratic, and I know x plus 8 is not a factor of this cubic, okay? So let's look at C. We want to evaluate the same cubic function here for negative 2, all right? So let's use synthetic division. We bring down the 1, multiply, add those two together, multiply again, add those two together, multiply again. Now when I add these two together, my remainder is 0, okay? So what that tells me is if I plug in negative 2 to this function, I get 0. Now the factor theorem tells us that if we get a 0 remainder, it means this is a 0 of this polynomial. That's going to help us graph it. It's also going to help us factor that further, okay? So if f of negative 2 equals 0, that means x plus 2 is going to be a factor of this. We can't factor this with any other tools we have. You can't factor this by grouping, okay? It's not a quadratic trinomial, so you can't factor it using any methods you've learned, okay? This is the way for you to factor this, using synthetic division. All right. In the next video, we'll go over using the remainder and factor theorems to help us completely factor some more complicated functions.